to talk about the issue of global warming in the context of relationship with rice production. My name is Shigeto Sudo. I belong to NARO, National Institute for Agro-Environment Science. Okay? Our country, Japan, is one of Asian countries and one of major staple food of Japan, of rice for a long time, more than 2,000 years or more. Okay. According to the Food and Agriculture Organization, FAO, for the year 2007, global rice plantation area covered 12.5% of the total crop plantation area. Share of paddy field area in Japanese all agriculture field is 54% in 2007 statistics. Now is almost same way. So 2.5 million hectares of paddy farmland supports Japan's staple food. So in this slide, let's move on to the issue of global warming in agricultural field. This figure shows one of the typical cultivation practice in Japan's rice paddy field. Rice paddy field in Japan, irrigated paddy is dominant. Water level is controllable except for severely drought or flooding season. We transplant rice seedling in April or May. After transplanting, water level is kept 5 or 10 centimeters above ground level. At the tillering stage, we drain paddy water until we can see small scale of crack in soil surface. The drainage of water is called mid-season drainage. So in Japanese stage, in Japanese saying, the mid-season drainage is called nakaboshi. Okay. After this nakaboshi season, mid-season drainage season, water level is kept at saturated condition in panicle initiation stage, followed by irrigated condition from 3 weeks before heading stage. Then 3 weeks after heading stage, flowering stage, we finally drain water to prepare machinery harvesting. Most of region in Japan, we can cultivate rice only one time per year. In India is another case, maybe, because the Japanese winter is very cold. Okay, methane is CH4 is one of major greenhouse gas on the earth. Rice paddy is one of dominant source of methane emission. CH4 methane in paddy soil is emanated by the activities of anaerobic bacteria, which is called methane producer, or methane production bacteria. Through reproduction of CO2 or the composition of acetic acid. So flooded condition in paddy is preferable condition for methanogen. On the other hand, methanogen activities weaken methane emission from rice paddy. That period is prolonged on intern or mid-season drainage. In water level. The figure shows source of greenhouse gas in the world. So in the left-hand side, we can see carbon dioxide, CO2 is a top share of 75% of global warming source among all greenhouse gases. For the origin of CO2, 56% is fossil fuel, followed by land use change activities, which reduce natural forest. Methane, CH4, is the second largest greenhouse gas followed by nitrous oxide, N2O. In the right-hand side, we can see the greenhouse gas emission share based on industry categories. Energy consumption, transportation, human life are top 3 activities, followed by industrial production, agriculture, and forestry. Then greenhouse gas emission share of agriculture activities are almost 30% in all industries. In this slide, I will talk about when methane is generated from the paddy field as the paddy field grows. You can see the difference in the amount of methane generated when 4 different types of water management are applied. Okay. This is continuous flooding condition. So every time water is flooding. Then second is 2 weeks mid-season drainage treatment. So in this figure, you can see mid-season drainage reduce drastically methane emission compared with continuous flooding. So another 1 week extending of mid-season drainage reduce much more, and 4 weeks is much more. So mid-season drainage is a very strong controlling factor of methane reduction in the paddy field. Okay. In paddy field, methane source are organic matter stored in the soil rice straw plowed into the soil after the previous year's harvest in a major cause of methane generation. Rice straw is one of fresh organic matter. Methane generation is relatively low when compost that has matured is plowed into the soil. So organic matter is not all is same way. So fresh rice paddy straw is methane emission is much more. Okay. Mid-season drainage in paddy fields reduce the water level below the ground. As a result, the surface of the paddy field will be dry enough to crack. Depending on the drainage and the nature of soil, the dry conditions and crack will change. Therefore, the optimum number of days for mid-season drainage varies depending on the soil types of the paddy field. We tested effect of reducing methane by extending the drying period in the paddy field all over Japan, 8 prefectures. So I will show one of examples of methane reduction in this figure. This is Niigata Prefecture's case. Normal mid-season drainage period in Niigata is 2 weeks. In this test, drying period were extending backward for another week and 2 weeks. Methane was reduced by 50% with a 1 week extension of, and 72% with a 2 week extension. So 2 weeks plus 1 week mid-season drainage reduce 50% methane emission. We need precise measurement system for GHG analysis. So I started to develop automated combined.
Hello? Sir, can you please click on the enter tab on your screen? It is not visible to us.
Not visible.
on the side.
Oh. Maybe not visible. No, nothing. Uh,
Now it's okay,
now it's
sir.
okay.
Now it's
We need a precise measurement system for GHG analysis. I started to develop an automated combined analyzer for three greenhouse gases, CO2, methane, and nitrous oxides in 1999. I spent 5 years emanating the idea and about 6 more months assembling this system. During the 2 years test of methane reduction, we conducted a methane reduction demonstration test, such paddy water management in 9 paddy fields in Japan. Methane emission differed due to difference in soil and soil temperature in condition. The average methane reduction result is about 30% by extending the mid-season drainage period. So I would like to introduce another case of the methane reduction in India. It is one of the farming methods of SRI to save water as much as possible and to cultivate paddy rice efficiently. SRI system of rice intensification is aiming is to get a lot of harvest. The main points of SRI farming method are as follows. Transplant only one young seedling, widen the planting interval. Irrigation water should be the minimum. So in this SRI method, we incorporated AWD water management. AWD is a name of alternate wetting and drying. In paddy field, it is common to continue cultivation while keeping the water at a height of about 5 centimeters above the ground. It is normal case. But AWD method does not add water while it naturally descends to minus 15 centimeters due to evaporation or underground run 15 centimeters to return it to the plus 5 centimeter water level. As shown in the illustration, the fluctuation of the water level is the form of a zigzag. As a result, the amount of irrigation water required for cultivation can be saved by about 30% with AWD compared to when keeping 5 centimeters or at all times. Okay. So due to continuous sunny weather in the dry season, the water level on rice fields tends to drop rapidly. So AWD frequently requires during the rainy season, water is added from the rainwater, so re-irrigation is less frequent. In the dry season, the effect of AWD reduces the amount of irrigation water by 50%. In the rainy season, right-hand side, the water saving effect is 80% due to the addition of rainwater. In this way, AWD irrigation has a great effect on saving irrigation water. In our test, the yield of rice was about 6.5 tons per hectare in Tamil Nadu rice paddy field, and no difference in water management conditions was observed between varieties. So the conventional farming, the continuous flooding method requires 30,000 kilograms of seeds field, but SRI requires about 7,500 kg. There is no difference in yield. AWD irrigation can reduce methane emission by 38,000 tons in the dry season and 42,000 tons in the rainy season. In addition, the amount of irrigation water is expected to be reduced by about 30% to 40%. So in this way, the combined use of SRI farming and AWD irrigation has the potential to save water and reduce methane in tropical paddy rice cultivation. So finally, we conclude this presentation. We conducted tests to verify the improvements of water management in order to reduce methane emission from rice paddy field at 9 experiment sites in Japan's rice paddy fields. So the longer length of mid-season drainage period was prolonged. The lesser amount of methane emitted even after the mid-season drainage period lasted as a whole. The combination of AWD irrigation and SRI farming is a very effective technique for climate smart agriculture in tropical paddy field. Thank you for your attention.